Dear students of the 4th year of the Faculty of Commerce, the English section, today we are going to discuss some questions in Chapter 5 that mainly speaks about the discounted cash flow approach, and you should be knowing the difference between discounting and compounding. Discounting means bringing the amounts back in time, and compounding means taking the amounts forward in time. And I wish you all have studied this before, because it is important in this point. Our first question here is asking about discounting at 14% discount rate to calculate the net present value of the following project. Here the project takes 3 years and it has initial investment of 1,000, and the first year will be having cash inflow of 500, second year 600, and third year 400. So we want to calculate the net present value of this project. The present value is the amount of each of the flow multiplied by the factor at 14% discount rate. The net present value represents all inflows minus all outflows, or the opposite, all outflows minus all inflows. So here we are going to use some factors from a table. It could be calculated on the calculator, but it takes a little bit time, and it's already known for each $1 at specific discount rate what would be the factor. So people at the statistics made us some simplified table. Here we are going to use table B to find our factors for the present value. If we are going to take amounts forward in time, so we are going to use compound interest rate, and you will notice that all the amounts, all the factors in the compounding interest has value more than 1, 1.04, 1.4 at 9 years for 4%, and so on. Here $1 at 20% after 1 year is 1.2, like you can see here. All the amounts you can see here for compounding are written in factors with amounts more than $1. On the other hand, table B, with the present value factor, you will find none of the factors has amount more than 0.9615. All the amounts are below 0.9615. Here all the amounts, here for example 0.3075, here 0.1619, and so on. So in order to get the present value of any dollar amount, you have to find which interest rate you are going to use. Here is 14%, as the requirement states. And for how many years? For year 1, year 2, and year 3. Find the intersect and select the amounts that you are going to use in finding the net present value of the amounts you should calculate. Here, this is the part where the discount rate is only 14%. Here we will take this amount for discounting any dollar amount for 1 year. Here discount at 14% for 2 years. Here the discount factor for 14% for 3 years. So writing these amounts here, and the cash flows of the project, here the initial investment and the cash inflows for first, second, and third year, multiply each amount by the factor and have the summation at the end here like this. This is our net present value that is required by the requirement in the problem. So it should be easy to find which factor that relates to our problem. Here we used 14% as discount rate, so you go to table B and find the proper factor in order to get the present value of the amounts in the project. Here you can notice that 500 that you will get after 1 year represent only 438 today, and this is the time value of 500, and 600 after 2 years represent only $461 today, and 400 after 3 years represent today $270 only at 14% investment rate. This is the meaning of discounting and compound. Compounding is opposite. Compounding $270 today to see its amount in 3 years. You will get the factor from table A and multiply 270 by the factor. You will find it to be $400, and so on. This leads to our next question. The question wants the estimation of the investment appraisal using the internal rate of return. Here we have another project that will last for 3 years, and it takes initial investment of 500, and we will get 200 inflow in the first year, 300 in the third year, and 200 in the third year. Internal rate of return is here an appraisal technique that is used by many managers, and it reflects the desire of the manager to have a specific investment for their amount of money. Here we find what would be the internal rate of return for these amounts in order to compare it to the preset internal rate of return set by the management. The first step is to use the IRR linear interpolation equation, and in this equation we suppose that we have a lowest interest rate at 4% and a highest interest rate at 20%. First we get the factors for 4% and multiply the amounts of the project, either outflow or inflow, by these factors, and get the net present value at the lowest rate. And the other part is to get the factors for the 20%, and these 4% and 20% are constants. You use them each time you are asked about IRR using linear interpolation. So at 4% we get the factors here, and at 20% we get the factors, and calculate the net present value of the project on one hand using 4% and on other hand using 20%. Like here we are using the first, the second, the third factors at 4%. As you can see, you take these numbers and write them beside the amounts of the inflows and outflows. The outflow is multiplied by 1 because it happens in year 0, but as long as you can see year 1 here, you multiply this by the amount at year 1. year 2 here, you multiply this by the amount at year 2 and so on. And these are the factors at 20%. You take the first 3 amounts to use as factors for getting the net present value of the project. As you can see here, our 500 initial investment has these amounts to be deducted from it in order to find the net present value of the project at 4%, which here is 147.48. And at 20%, the net present value of the project is minus 9.28. And this amount would be a proper amount each time you might find this negative sign each time you get some present value of outflows minus inflows for 20% discount rate. Don't get terrified when you see this negative sign. So what's the next step? First, in order to find the IRR, you get the net present values of the amounts at 4% and at 20%. Then you use the equation used in the chapter here. This equation is at page 80 in the papers you are supposed to have. This equation says that IRR equals the low discount rate, which is 4% in our case, plus low rate net present value, the net present value that we have calculated using the low interest rate, divided by the low rate net present value minus the high rate net present value. And remember that already in our calculations that we already have a negative sign. So you pay much attention in these calculations in order to get the IRR on the right way. And then we multiply the amount that comes out of this calculation by the high rate minus the low rate here, 20% minus 4%, that is 16% here. So taking this to our next step, this is the net present value at 4%, and this is the net present value at 20%, and applying the equation here we write 4% plus 147.48 divided by 147.48 minus another minus 9.28 that is already is the outcome of the net present value at the highest rate here, multiplied by 20 minus 4%. This will give us 19.05% to be the internal rate of return that the problem is asking us to find out. This leads us to the last part of the chapter. We have discussed in chapter 3 the payback method, and as the doctor said, one of its main disadvantages that make many managers don't use it is that it ignores the time value of money. So what is going to happen here is to adjust it to discounted payback period and get at a 10% discount rate, we get our discounted payback period. So first these are the amounts that we are going to use from the table B. Take how many years, you take the factors according to how many years that you are going to find. Writing the amounts, like you can see, the first investment, the initial investment, and these amounts of the cash inflows for the first, second, and third year, and multiplying these amounts by the factor for each year, getting us the payback period for this 500, and here it equals to 2 years and 0.47 of a year. Here you can see that this is the remaining amount in order to reach 500, the initial investment, and this is the amount that present value of the cash inflow for the third year, and we want to know how many days or how much of a year we can get the 70.26 out of 150.26. So here we find the fraction of the year to be 0.47 a year, less than half a year. So here the discounted payback period is 2 years and 0.47. This leads us to the end of the examples for chapter 5. I wish you all followed what we said, and please leave your comments in your questions in the comments section, and have a nice day.